Okay, so I'm back to talk about the depth mic again, and I grabbed the interchangeable handles that came with this set. So it's a 0 to 3 set, and I'll just show you how to demonstrate, or I'll demonstrate how to change the handles. So you just twist off the cap and pop out your 0 to 1, pop in the 1 to 2, slide it on, put the cap on, and you're ready to go. Keep in mind, this is the ratchet, and this is where the cap twists, so every style is a little bit different, so, take a look for where it separates, but typically it'll separate with the same size diameter as the body here. And then we can grab a 2-inch block, and we can check our full range of travel. So get close. And what do you know, there's a little bit of error there. So, hold on. It seems to like the white background when I do this. It was a little bit, didn't quite close on 0. Oh man, I don't know why you guys can't see that in this video. But you can see it very clearly on this camera, so I apologize for that. But this is why I record from both angles, so that you can see exactly what I see. But it's about 3 or 4 tenths off from 0 across that whole travel, and that's not surprising. I would maybe try to adjust the sleeve if I could, and try to get that closer to 0. If I'm working with steps that are 2 inches and 3 inches long, then maybe I need to just calibrate it for that range, rather than calibrating it on the rock at 0 and then putting in a bigger anvil. That's why I like to check with the Joe blocks. But I mean, there's not much else to those mics, so we're going to move on to the groove micrometer, like I said at the end of the last video. And unfortunately, I don't have one of these with me. If I can get one and I can record a video, I'll try to show you. Unfortunately, the way groove mics work is that you're typically on some internal features, so it can be hard to show on camera anyway. But when you take a look at a groove mic, the business end here has a couple of anvils, which I've drawn a few different applications for those anvils, but you can measure the groove, a negative groove thickness, a positive groove thickness, and then you can do outside steps, inside steps. But basically, you can register on either side of each flange. So you can register on the top here, or the inside, on the inside or the outside here. It doesn't really matter. And a typical, if I were pretending this were a groove micrometer, and when you look at your scale, you're gonna have 2 scales. You're gonna have a scale for the anvils that register on the outside, and a scale for the anvils that register on the inside. So you have to be really careful, because basically the scale is accounting for how thick the anvils are, and it's offsetting the 2 scales by that thickness. So you gotta be really careful. There will be a diagram that basically will say, 2 arrows will say, okay, I'm measuring from the inside anvils, or 2 arrows will say, okay, we're measuring from the outside anvils. And how you use this, you can measure internal grooves. So sometimes O-rings will have a very specific thickness for the O-ring. Snap rings or lubrication rings. The groove micrometer itself will not measure the diameter of these grooves. You'll need other tools for that, which we've talked about in some other videos. But this is just talking about the thickness of the groove or the flange. Some weaknesses: you are registering on some small surfaces, not just the anvils themselves can be pretty small, but also the part flanges and rings tend to be very small as well. So you gotta be really careful to get perpendicular and flat contact on your grooves. You gotta hold it straight and parallel to the hole that you're measuring the groove on. There are multiple scales, as I mentioned, so try not to confuse yourself. The calibration for all measurement methods is a requirement. So, you can imagine you're using the inside jaws a lot. They wear a lot. The outside jaws don't wear. Well, you need to calibrate both sets of jaws, just like with a caliper, which has multiple applications for its different jaws that it can measure with. It's no difference for a groove micrometer. And that ratchet touch, it's going to be different. It's going to feeling it. It's going to take a lot of practice to get your feel down. And I don't rely on the ratchet at all because I feel like I always get false readings as I try to get everything perpendicular and parallel. So I think this is a good place to work on touch feel instead of using the ratchet. And as I said, you have some different methods that you can use. I do want to point out, the groove micrometer is set up for measurements with the inside jaws and the outside jaws. They're not typically set up where you use the outside jaw of one and the inside jaw of another, although many prints sometimes are set up this way. So you can do a direct reading with this method. Hold on, let me keep fixing the pointer so that's visible. So you can get a direct reading from, inside jaw here, outside jaw here. But the trick is your scale, your direct, it's not going to be a direct reading here. It's going to be a direct measurement, but you're going to have to adjust for the thickness of basically one of these anvils. So the two scales are either accounting for both thicknesses here or no thicknesses here, right? The thickness of the anvil is not involved on this measurement, and the thickness of the anvil is involved on both anvils on this measurement. But for this one, there's only one thickness involved here. There's no thicknesses here. So you're going to have to measure one of your anvils and do a little shop math. So it's up to you how you want to handle it. It depends on how your print is set up and how complicated things are. But if you can physically do it, it's kind of like working with a depth mic. It's kind of like working with a depth mic, but with a disc at the end. So you're just not going to get a direct reading. And just be careful when you go to do it. If you haven't done it a lot, you're doing it for the first time, be really careful about your readings and your shot math and try to verify. You may be able to verify some of these checks using I don't have one here, but using a drop gauge. You can set up your part vertical, get a drop gauge with an angled tip. Your angled tip could potentially measure some of these distances as well and clear the rest of the part. So something I've done a few times. I've had to do this on some parts, and once I got the hang of it, it actually was pretty useful to get a direct reading, and I felt like I could control it and do it. I just had to do a little bit of shot math with the thickness of one of these anvils. So if I can get my hands on one, I'll record a video demonstrating it, but once again, it's kind of a difficult video to show you. The outside portion of it would work pretty much like a disc mic. There's almost no difference to comparing to a groove mic and a disc mic. It's pretty much the same here, except with a disc mic you can only do the outside groove, but with a groove mic I would actually be able to do this inside groove also and measure how thick that is. So since I don't have one of those, I have to use a caliper, or I can use a pin gauge, a Joe block. You could do a lot of other things, but a groove mic is also one application where you could do this measurement as well. And it works just the same on the outside as the inside. So when you have inside grooves, that's when it's really the best tool, as many of the other tools won't be able to. All right, now we're pretty much at the end of talking about different styles of micrometer. We're just going to talk about how you can take a typical OD mic and you can attach a tip onto the anvils and get whatever style you need. So this is a very cost-effective way to get all the different styles you need and not have to buy a bunch of different mics. Not only for like 0 to 1 mics, but you would need to buy them for 1 to 2, 2 to 3. If you needed blades and discs in those size, that's a lot of mics you have to buy. But you can only buy, you could just buy one set of tips and put them on any size OD mic. So I like to do this a lot. I've done it with thread gauge attachments to turn a typical OD mic into a thread mic. That's a great application that is very cost effective. There's another style where instead of having this tip that slides on, you can actually buy micrometers that are set up for multiple tips, and they will slide in and register a lot more securely than these rubber tips that kind of grab onto the outside of the spindle. So I'll demonstrate that in a minute. Let's talk about some strengths and weaknesses first. Like I said, you can transform any OD mic into other styles and it's less expensive. But some of the weaknesses, you do get some stack up error as you're adding more pieces to one end or both ends. You have to account for the thickness. You have to make sure that everything's perpendicular and straight. Otherwise, you may be putting new anvils on off center or crooked and messing up your reading that way. You have to make sure everything's flat and clean, right? No dust, no oil, no chips. You have to recalibrate each time you add the pieces, right? You've got to grab a Joe block and verify not only that the Joe block is zeroing, but also the stack up is correct and what you think it's supposed to be. And then you have to add or subtract your anvil stack up to account for your measurement. So one style of mic that I have here, it uses that interchangeable anvil style, but it has a more accurate version where it slides into an inside diameter. Is I have this anvil mic here where I can pull this I have this thread mic, pitch micrometer. Sorry, I'm struggling with the words right now. Pitch micrometer, where I can change this out for other anvils, and I can actually, with this style, I can change out both ends. So I can change out both ends to get different pitch measurements. And I talk about this gauge in great detail in the thread measurement video. And I do that mostly because I want to talk about all the thread gauge measurements relative to each other. So I'm not showing you too much about it in this specialized micrometer video, but this is a specialized micrometer for measuring threads. And I've got a bunch of different anvils that I can just slide in and out depending on my need. So these ones don't go in. There's other styles where, this style, as I said, it goes inside of a diameter and it registers securely. It has a stop, a very precision stop for it, and then I can check zero by closing it. There's other ones where instead of having the other common style would just add a couple of pieces to both ends or one end. Maybe you just want a round side on one end and you still want a flat on the other. And that would just add some thickness to your overall micrometer. But I recommend you have a set of these because you never know when you're going to need it, and you may not have the right size mic, the right style mic. But if you have an OD mic, you can transform it into what you need. So very handy. Now we're going to talk about accuracy in general for all of these gauges. They all, as I kind of demonstrated on each one, they have their own calibration and accuracy specifics, but in general it's pretty close to an OD mic because it is a micrometer and not a caliper or a scale or any other version. It's, you know, typically close to an OD mic, but also typically a little bit more error. So take a look at your manufacturer specs to be sure. And then the more complicated it becomes with interchangeable tips and accessories and shapes of tips, the larger the error is going to be. And the last one there, it is size dependent. So if you're working with larger and larger and larger mics in different styles, whether it's a depth mic anvil getting larger, or a blade mic getting larger and larger and having blades, well, you're going to get more error as it grows as well. For calibration, each gauge will have the different anvils to calibrate, but you follow pretty much the same procedure. You saw me use Joe blocks. You saw me close it at 0 and hold it up to the light and check for an issue as well to look for wear. And then check each assembly. So whenever you change out the tips, you change out the anvils, double check that 0 remain, because in practice it usually, well, not usually, but often does not maintain the same 0 it had with the other anvil. And that's just due to the nature of moving parts and different wear patterns that can happen. So keep an eye out for that. When it comes to handling and cleaning them, it's pretty much the same as OD mics. Keep your anvils clean. You can go ahead and when you're zeroing, grab a piece of paper and drag the anvils across. That will still grab any chips and oil that might be there. You need to develop the right feel. Each gauge will have a different feel. Won't feel like the OD mic because of the different shapes of the anvils. And again, temperature differences matter, so treat it like it's a typical OD mic and keep it the same temperature as your parts. Don't handle it too much. Some people will say, and they're right, you will add heat to the gauge the more you handle it, and in precision applications that might be a problem. It's not too much of a problem usually when you're working with these specialized style. You're not working with the most tightly precise parts. So you typically have a little bit more tolerance than you would with an OD mic. Maybe you have a really tight tolerance outside diameter, so you use an OD mic. But when you have these different shapes of parts, as the complexity of the shape develops, you usually get a little more error, a little more tolerance. So that next one, verify the anvils are registered correctly. That's always true. You go ahead and clean them with a light solvent. Don't use a compressed air, but just rub them down with a nice light solvent. And feel free to disassemble them when they feel like they might be tight. Disassemble, put a couple drops of spindle oil in whichever micrometer you're working with, and give it a little bit of lubrication. And while you're there, you can inspect it if anything's gotten in there to try to remove it. So in summary, you have a wide variety of specialized micrometers for many situations, and I covered the most common ones that I think you're going to see. I do apologize for not having all of them available, but for the most part, a blade and a pin micrometer, they're going to act just like the disc micrometer I showed you in the OD mic, and the only one that's a little bit different is the groove mic. Go ahead and check your catalog for manufacturer specs and ask them. You can always email these manufacturers, these big ones, and say, look, this is my application. What do you recommend? Sometimes they can make something. I've actually asked in the past, I've said, hey, I need a multi-anvil micrometer, and all of your multi-anvil micrometers have like a flat end for the moving spindle, and I want a round end. And they were able to, we were able to work something out. I got 2 round ends meeting, which is what I needed for that application. So feel free to study those catalogs and contact those manufacturers. You do get to maintain that micrometer accuracy, although it's and resolution, although it's typically a little bit more error, and you don't always have the 10th vernier scale. Like this depth mic didn't have a 10th vernier scale. This, let's see, this disc mic did not. This tube micrometer did, so you'll get it sometimes you won't. Yeah, that's the fourth bullet point. And then the last one, I like to emphasize, practice is necessary for all of these to measure and get accurate results. So the first time you use them, try to verify with something else if you can, and practice your measurement, practice your pressure and your feel. So thank you guys for watching this video. I hope you learned something. I do want to thank the Laney Machine Shop in, the Laney Machine Technology Program, Community College in Oakland, California. I'm using one of these parts that they're letting me use and to demonstrate some of these tools. And they have a great program there for manual machining and CNC machining and metrology, which is what we're talking about in these videos. CAD design, blueprint reading, maintenance. They have a lot of good classes there if you're interested in getting into manufacturing as a career. They have classes, apprenticeships, certificates you can earn. If you took all the metrology courses that they require, if you took all the machining courses they require, you could get a certificate in one of those categories. I think they have another category as well. And you can get an associate's degree as well. If you take all the classes that are required, you can get a 2-year associate's degree. And if you do any of that, you're going to be setting up your career very nicely. A lot of employers are looking for that classroom experience and that mentorship that happens in classroom settings. So please check out Laney College in Oakland, California. If you're in the Northern California Bay Area, the machine technology program's got a great setup there. You'll learn a lot. And again, please check out my website, pragmaticmetrology.com, for more of these training videos on gauges and the concepts that help you with these gauges. And I thank you for watching. I look forward to the next one. And my next video, I'm going to do a quick kind of exercise with all of these specialized micrometers. So check that video out as well. Thank you for watching, and I'll see you next time.